Okay, folks, today we're going to be talking about the second category of research methods in this video, which are the correlational methods. And so we have covered descriptive methods in a previous video. We'll talk about experimental methods in a future video. And right now we're focusing on this second category of research methods, the correlational method. So let's get to the next slide here. And let me start by telling you how important correlations are for you to understand for life, not just for this class. I talk to many adults now that are my age that do not understand correlational data. They think that when a correlation or relationship is reported, an association of some kind, that means that one caused the other, and that's not the case. And so I want to explain to you what the correlational method does do, and then you can understand better what it doesn't do. And so that's kind of where we're going to start out. You hear about correlations reported all over the place. You hear about it in the news and on the radio. You're reading on the internet and you see that there is some kind of relationship or connection or association between two variables or two things. So for instance, you may read an article and it says, oh, there's a relationship in this study has been established between consuming omega-3 fatty acids and Alzheimer's disease. Or, oh, there's an association between smoking cigarettes and the development of lung cancer. Or you may just use it just in general terms when talking to a friend. Your friend calls you and says, well, I got fired from my job. And you say, well, why? And the person says, I'm not sure. And you say something like, well, do you think there's a connection between the way you yell at customers and your being fired? You are also pointing out a relationship, a connection of some kind. That's correlational in nature. So let's take a look at how we define correlational methods first. First, correlational methods show us how strongly two things or variables are related or associated or linked or connected. These are all terms that suggest correlation. And what happens when you scientifically produce a correlation, what you're doing is you're collecting the information you need and you're kind of processing that statistically. And you come up with what is called a correlational coefficient. Doing this, it can be done by hand. You can actually do a correlation yourself on paper with a pencil, but it's beyond the scope of this class. But what that number does is it tells us two things about whatever relationship you're looking at. It shows us the strength of that relationship, and it shows us the direction of that relationship. So I'm going to show you kind of how this works, and then I'll give you a couple of examples. So here, and what I'd like to try to do is I'd like to try to use the pen. Let's see if I can use the pen. And then pen color, maybe we can do yellow. Okay, so the number of a correlation tells us the strength of that relationship. So let's just draw a little number line. Now I'm using this on the computer, so it's kind of funny. Imagine you have a number line going across like this, and then, if you're making a number line and you had 0 on one end, right next to it would be 0.1, and then comma, point 0.2, comma, 0.3, and I'm just going to leave the commas out because that will take forever. 0.4, 0.5, right about halfway through the number line, 0.6, 0.7. So these are all fractions of 1, 0.8, 0.9, that guy, and then you get to the whole number 1. So here's your number line. You got 0 down on this end, and then all the way up until you get to 1. So when this correlational coefficient is calculated, you come up with a number between 0 and 1. You would hardly ever get a 0. Usually there's just some tiny, minute fragment of a connection between any two things. So usually you wouldn't bother studying something if you knew already it was a 0 correlation. And then on the other end of the spectrum, if it were a 1, that would mean that it was a perfect relationship. In other words, every time one thing occurs, the other one occurs with it in an exactly predictable way. Like if I open the door, then I shut it. I open the door, then I shut it. Then I open the door, then I shut it. Every time it happens together, you wouldn't bother looking at that and studying that either, because you already know it's a perfect correlation. So the number reveals the strength. So when we're looking at these numbers, right in here, between 0.7 and 0.9, this is usually thought to be a fairly strong correlation. And so a strong correlation means that when one thing happens, the other thing also happens almost all the time. So it's very predictable. One predicts the other. Right in here, 0.4, 0.5, 0.6 or so, this is considered moderate. And I'm just going to write MOD for moderate. That's a moderate correlation, meaning as one thing happens, then the other thing co-occurs with that some of the time. Yeah, some of the time. And then in here, 0.1, 0.2, and 0.3, this is very weak. So if you were a researcher and the first thing you did was look at the number, the correlation that you got between the two variables or two things that you're studying, where would you do a crazy happy dance? Where would be your crazy happy dance? Would it be down here with a weak correlation where one variable hardly ever predicts what the other one is doing? The association is very weak. Or would it be over on this end of the scale where when one thing does something, the other one almost always goes along with it? Let me ask you, do you think there's a relationship between how much time you spend studying and your final grade in this course? How does that relationship, how predictive do you think that is? Do you think that's strong, how much time you spend studying in your final course grade, or moderate, or weak? Well, I can't say because I haven't studied this, but my guess is that it probably is fairly moderate to strong. That the more you study, the more likely you are to do well in the course. Sometimes this doesn't happen. It's not a perfect relationship. Sometimes I have students that come to my office and they say, you know, I've been studying all the time. Here's all my notes. Look at all the stuff I've done. And I still did very poorly on the recent exam. But usually when a student spends many hours studying, reviewing the material, and so on, they usually do better in the course. But again, it's not perfect, which is why it's not, for example, a 1. If it was perfect, like a score of 1, that would mean for every so many hours spent studying, your course grade would go up 1 letter grade. So for every, 40 hours you spent studying, you would go up 1 letter grade. Every single time you spend 40 hours, it goes up again, another one, it goes spend 40 hours, it goes up another one. That would be a perfect relationship. But again, we don't study those. And so this is strength. Strength of relationships. So you would do the happy dance down at the end down here because that would be, this is highly predictive. Most research that's been published kind of falls in the middle somewhere. So they're predictive of one another, but not necessarily very strongly predictive. Down here you see that the number also has something else that goes with it that tells us the direction. So the direction is indicated by a plus or a minus sign. So the plus sign would mean that it's a positive correlation, and the minus sign would mean that it is a negative correlation. So it would be, for example, just like if you put 0.8 and then you put the sign right in front, just like you would when you're doing normal math. But it means something different to normal math. It doesn't mean that it goes negative down the other side of the number line. Now, sometimes textbooks, when they explain this, they'll actually show it going the other direction, meaning that it's a negative or an inverse relationship. Another word for negative relationship is inverse. But it's too confusing to think about it that way. It's easier to think about it on a number line, the numbers between 0 and 1, and that tells us the strength. And then you have the sign, which is either positive or negative. So what does a positive sign mean? A positive sign means as one thing, whatever it is, goes up, the other thing also goes up. So as number of hours spent studying increases, so does final course grade, for example. So we can also do it the opposite. As this first one goes down, what do you predict about the second one? It's also going to go down. So they go up and down together. And how well they travel together is determined by how strong the relationship is. So let's look at the negative correlation. This one you would put into a sentence like this. As that first one goes up, this is negative. So if positive means they both go up and down together, side by side, they're going up and down together, what happens in negative? It's opposite or inverse, meaning as the first one goes up, what happens to the second one? It goes down. As, oops, got a little too far ahead of myself. Now I lost my stuff. Well, that's too bad. But no mind, we'll just continue on. As the first one, so this is for negative, as the first one goes up, the second one goes down, or you can reverse it. As the first one goes down, what happens to the second one? It goes up. So the relationship here is one traveling upward while the other one is predicted to go downward. So you can think of a negative correlation for yourself. As age increases, what's something that decreases for people? So once you're an adult, as your age starts to go up, what's something that decreases and goes down? You might say, bodily comfort. So the body feeling good, that decreases as age goes up. That would be an inverse relationship. So if the person had a lot of bodily comfort, then you would predict what about their age? That they were at a lower age. So in our example about how much time you spent studying and then your course performance, that one, as time spent studying increases, then what happens to your course grade? It also goes up. Right? So what students often do is get confused about the two of these, the strength and the sign. So what I'm going to recommend to you is on a test, for example, where you're asked to identify the strength and the direction of something, a relationship, you should first look at the number. First decide, is this weak, or is this moderate, or is this strong, based on the number. Then, after that, you look at the sign. And again, the sign is not positive or negative, good and bad, or positive or negative further down the number line in the negative direction. Don't associate it with regular math. Think about it, it's just direction. That's it. So what's the relationship like? Sorry, my writing is atrocious on this thing, but I think this will still help you if you can manage to read it. Okay, so let's go forward. And what I do in my in-person classes is I ask for folks to give me a shoe size and a height. And they also have to tell me if they're wearing male shoes or female shoes, because in America, we have different sizing for male shoes and female shoes. In other countries, they don't do this. It's a little bit easier with the sizing that way. But what I do is I ask folks to share their shoe size and their height. And then what I do is I graph it out. So here's across the bottom shoe sizes, and here's going up height. So you see 6'4" be 6 feet 4 inches, and so on. So here's, you're shorter on this end, you're taller on this end, your foot is smaller on this end, your foot is bigger on this end. So let me ask you, what would you predict about shoe size? What kind of relationship is this? First of all, think to yourself, well, is it strong or moderate or weak in relationship? In other words, does shoe size in your experience tend to predict height? And then think about kind of what strength that might be. And then direction, and we're going to look at the direction in just a minute. Okay, so let's look at the next slide here. So here's one of the classes that I mapped out. And this is called a scatter plot. The fancy term for this is a scatter plot. I've just hand drawn it. And I think in this case, let's see, I used orange for females and I used like a black or blue for males. And I've plotted them all out. So each of these can be plotted into this graph. Now you do this with correlations. You make graphs always, scatter plot graphs with correlations always. And so you plot out the data. So like this person was wearing a size 6 and they were about 4'9". This person up here was wearing a size 12 shoe and they are 5'10". So do you see how that works? You go up and then you match on this side. Like that's how you figure out where to plot the data points. So when you look at this, if I asked you to draw a line through this data, a straight line, kind of through the middle of those data points, in other words, half the points would be above or below, some may fall right on the line, but half would be above and half below. Do you think you could do it? Where would that line be? Would it go this way? Would it go this way? Which direction is it headed? So most people tell me that they see it right, well, it's kind of hard to draw with this mouse thing, right in here somewhere. So imagine that line were straight and that half the data was above and half the data below. To be a little more accurate, it would probably be a little further down this way. But point being, you could do it. You could draw a line in the general direction. And what we find is that, look here, when you have a larger foot size, you are more likely to have more height. And look here, when you have a smaller shoe size, you're more likely to be a little shorter. And so this trend like this, as height goes up, so does shoe size. That's a positive correlation. So this, a scatter plot, reveals the direction of a relationship. You can tell if it goes this way, it's positive. If it goes this way, it's negative. Just by looking at the scatter plot. The other thing you can tell as a researcher, and this is where you always go first actually to look. You don't even really look at the number and the sign first, you look at the graph, because the number and the sign are kind of connected to this graph. And so if you see it visually, you can say, aha, this is a positive correlation, and it's probably moderate. If it were perfect, where would you expect the data points to be on this line? The data points would fall in a predictive manner and make a perfect line. They'd be perfectly spaced out, the data points, and they would make a perfectly straight line. There wouldn't be any above or any below. Of course, we know that correlations people study are not perfect, so that never happens. If it were a zero correlation, so really, really weak or zero, what would you see with the points? They would be scattered all over the place. I could say, hey, I want you to draw a general line through those data points, and you'd be hard pressed to do it. You'd have trouble doing that. Well, does it go this way or this way or this? I can't tell. That would be a very weak correlation. Here, what we see is that they're kind of centered around this line, and some of them fall on the line and some of them away, but in general, there's a pattern here. There is a relationship or an association here. If we calculated it, it's probably a moderate correlation. And this fits with your experience, doesn't it? If you're walking down the street and you see someone with enormous feet, just enormous, even bigger than size 14, just huge feet, and you look at them and they are a very tiny person, you would be shocked, wouldn't you? You might even laugh. That's one reason that clowns look funny. They wear these big, big shoes and they tend to be much smaller than their shoe size in terms of their height. And so it looks different than what we expect because we're used to seeing it in a certain way in the real world. So also, if you saw someone who was quite tall and they had very, very tiny feet, certainly that happens, but it's not typical. You might notice it like, whoa, you have very small feet and you're 7 feet tall and you're wearing a smaller shoe size than me. That would be surprising because again, there's a correlation here, a relationship that allows us to predict some things. Now, here I've mapped it out just so you can see it in a different way. Here's your no correlation in the middle. Here's your low correlation to the side of it. Kind of the data points are out. And then high negative, and then perfect negative. They're all going to fall in that line. And then the opposite direction. Here's the positive side going this direction. So positive, they go this direction. Negative, they go this direction. And the closer they are to the line, the more predictive the relationship is. Now, this is why I have a bit of a bone to pick with some of these magazines that I see. Sometimes I'm at the supermarket and I see a magazine. And I get really upset because I see that these magazines are reporting correlational data in a way that manipulates what the person thinks about that data. So the first thing to note about correlation is that correlation does not necessarily imply causation. That's just a fancy way of saying just because you have a relationship of some kind, even if it's super, super strong, 0.9, for example, even if you have that, it doesn't mean that one thing caused the other. So correlations tell us how strongly two things co-occur, but they don't tell us that one causes the other. They happen together, maybe a lot, maybe most of the time, but it doesn't mean one causes the other. You can think about it like this. Think about colds. So you get a cold, and you can get that cold from a variety of places. Where can you get a cold from? Think about it. Usually my classes, people say things like, oh, well, you went out with wet hair, or, you didn't wash your hands well, and then you touched your face and you had some germs on it. You lick the door handle. That could cause a cold. So you could say, oh, a cold is caused by, licking, a cold is linked to licking door handles. And there's a strong correlation there. When you lick a door handle, you're likely to get a cold. That's a relationship. That's a correlational statement there. But there are all these other things that can cause colds too. So you could be kissing someone that has a cold. You could be, worn down, lack of sleep, and that could cause a cold. So a correlation doesn't say that one causes the other. Experimental research is what gives us that sort of information. So back to why I hate most magazines. So if I'm at the store, one time I'm at the store and I'm standing there and I pick up this magazine, and they had an entire section in this magazine about some research that was done with pomegranate juice or pomegranates, demonstrating that there was a relationship between pomegranates and longevity, how long you live. And then, so that's a correlation. They said there's a relationship between pomegranate consumption and longevity, how long you live. And they didn't in the magazine report the correlational coefficient, which really got me irritated because it could be there's a 0.1 correlation and that's it. That's extremely weak. That means nothing really in terms of relationship. It's not predictive at all. So it didn't tell what the value was, number one. Number two, it then set about taking up, I don't know, 6 or 7 pages of the magazine about where you could find the best pomegranates, where you could get this juice, where you could get pomegranate trees to grow in your yard. I happen to adore pomegranates, but the suggestion in the magazine was that somehow this was causal. One causes the other. In this case, the way they wrote the article, they were suggesting that consuming pomegranate juice would increase your lifespan, which may well be the case, but correlational data does not tell you that. So that's why I don't like most magazines, because they pick up on a correlation and then they just run with it. And they go on and on and on about it, but yet it's just a correlation. There is a relationship, but they're suggesting that it's causal. So why do people do correlations at all? It helps us make predictions. So if we start to see, okay, well, these two things are highly associated with one another, then you can start to make predictions about, oh, okay, then you're more likely to get diabetes if you're eating a high glucose diet, for example. So you can look at risk. So correlations help us with risk and making predictions about what might happen if these two things are happening together. It also helps us because a lot of times there are ethical concerns that prevent us from doing the gold standard of establishing cause and effect relationships. One causes the other is the experiment. But sometimes you can't do that because it's not ethical. So for instance, if you wanted to look at like an opioid drug and its impact on the ability for students to pass my class, I couldn't come in, randomly divide you into 2 groups, give half of you an opioid drug, and then the other half a placebo, or one that does not have any opioid drug in it. Because it's not ethical, it's illegal, it can cause addiction, it can cause all these problems. I can't do that. But what I could do is I could look at folks who are already using such medications and try to establish a relationship. So also, correlations tend to be less expensive. And so what folks will sometimes do is they will do a correlational analysis to see if it's worth spending the money to do a bigger experimental investigation. And then they'll use that kind of as their springboard, their first investigation. Okay, is it worth it? Is there something here? Is this worth investigating? So that's another reason that people will do correlational kinds of evaluations. I hope this video is helpful and not more confusing. My idea was that you would read the textbook and then you would sit down and watch this to get a sense of what this stuff really means. If you found it confusing, please reach out to me. I am happy to help you with it. I really, really want you to understand correlation so you don't get misled by some of the things that are written out there and that you come across in your daily life. And it will also help you do well in the class.